This is day 79 of the same chapter, chapter 14. This is the last part, part 6. Exercise 14, question number 35. Find the equation of the straight line passing through the point minus 4, 7 and the point of intersection of lines 3x plus 4y minus 5 is equal to 0 and 4x minus 5y plus 7 is equal to 0. I'll come to this later. First look at this. Find the equation of the straight line. I've just drawn the straight line. This is the straight line. Line 1. For this you have to find the equation. Equation is not known. So find the equation of this straight line passing through the point minus 4, 7. So this straight line passes through the point minus 4, 7. So that's one point through which it passes. And it also passes through the point of intersection of two lines given here. This line passes through the point of intersection. This is the point of intersection of these two lines, line 2 and line 3, whose equations are known. Line 2's equation is 3x plus 4y minus 5 is equal to 0. This is line 2. And line 3's equation is 4x minus 5y plus 7 is equal to 0. That's line 3. This one. Okay. Wherever these two lines intersect, this first line also passes through that point. That's what the question says. So first you have to find this point. Look at line 2, you know the equation. Line 3, you know the equation. If you know two lines equation and if you have to find the point of intersection, usually when we solve simultaneous equations, you will get value of x and y. That x and y which you get is actually the point where the two lines meet. Okay. So this is a simultaneous equation, this is a simultaneous equation. Solve both this, which means you will get x and y value. That x and y value is actually the point where line 2 and line 3 meet. Okay. So take these two equations and solve them. Okay. So that's the first thing that we'll do to get this point of intersection. So on solving line 2 and line 3's equations, line 2's equation is 3x plus 4y minus 5. I've shifted the 5 minus 5 that side is equal to 5. And the second one is 4x minus 5y and plus 7 goes that side, becomes minus 7. So this is equation 1, this is equation 2. Now, x is not equal, y also is not equal. Because these signs are different, I'll make these equal. Okay. So LCM of 4 and 5 is 20, which means this has to become 20. So this whole equation has to be multiplied by 5. This has to become 20, which means the whole equation has to be multiplied with 4. So multiply the whole equation by 5. This will become 15x plus 20y is equal to 25. And this whole equation is multiplied by 4. So that 16x minus 20y is equal to minus 28. And then add both these equations. 15x plus 16x is 31x. This will get cancelled. 25 minus 28 is minus 3. So x is equal to minus 3 and the 31 goes to the denominator. Minus 3 by 31 is the value of x. We are solving simultaneous equations. So we found only value of x, which means you still have to find the value of y. Okay. So to find the value of y, substitute the value of x in equation 1. So substitute value of x in equation 1. Equation 1 is this one, 3x plus 4y is equal to 5. So 3x, x value is here, plus 4y is equal to 5. So multiply the 3 inside, minus 3 into 3 is minus 9 by 31, plus 4y is equal to 5. Keep the 4y here, okay. I've done it here. 4y on the same side, shift this that side. 4y is equal to 5 plus minus 9 by 31. Sorry. This comes this side, plus 9 by 31. So 4y is equal to, LCM is 31. So 31 into 5 is 155, plus the 9 remains the same. Okay. Shift this 4 this side. Y is equal to 155 plus 9 is 164. Divided by 31 was already there. And this 4 goes to the denominator into 4. Okay. 4 and 164 can be divided. That will give you 41. So y's value is 41 by 31. So we found x here, we found y here. This is actually the point of intersection. Therefore, point of intersection is x coordinate is minus 3 by 31 and y's coordinate is 41 by 31. That's for now. So the point of intersection is minus 3 by 31 and 41 by 31. Look at this. This is the point of intersection whose coordinates are minus 3 by 31 and 41 by 31. So on this line, line 1, whose equation you are going to find, you know this point and you just found this point. So 2 points are known, so you have to find its equation. So I have drawn the line separately, so it's easy for you. Therefore, equation of line 1, this is line 1. One point through which it passes is minus 4, 7. The other point is this one. Okay. So first one I have taken as x1, y1 and the second point I have taken as x2, y2. So because you know 2 points on the straight line, the equation is given as y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. Look at these values and substitute. So y remains the same, minus y1, that's minus 7, divided by y2 is 41 by 31, minus y1 is minus 7, is equal to x remains the same, minus 4, that's plus 4, divided by x2 is minus 3 by 31, again plus 4. To simplify this, you will have to find LCM on both sides. Okay. Y minus 7 remains the same, LCM here is 31. 41 remains the same, minus 31 into 7 is 217. For this side, x plus 4 remains the same, LCM is 31, minus 3 remains the same, plus 31 into 4 is 124. Okay. Now look at this, you can cancel this 31 and this 31. And to simplify, y minus 7 is the same, 41 minus 217 is minus 176. And x plus 4 remains the same, 124 minus 3 is 121. Both these can be divided by 11. This can be divided by 11. 11s are. This can be divided by 11 once and 6 times. That's minus 16 times. Okay. Now cross multiply. Okay. So that I have shown this side. So y minus 7 divided by minus 16 is equal to x plus 4 divided by 11. Cross multiply now, 11 gets multiplied this side, 11y minus 77 is equal to minus 16x, minus 16 into 4 is minus 64. Now rearrange, this comes this side, 16x plus 11y, this comes this side, minus 77 plus 64 is minus 30 equals 0 is the equation of line 1. Okay. Next. Question number 41. Find the equation of the perpendicular bisector of the line segment joining 2, 7 and minus 4, 1. Find the equation of the perpendicular bisector. We'll come to that later. Of the line segment joining these 2 points. There is a line segment which joins these 2 points. This is the line segment joining the 2 points 2, 7 and minus 4, 1. This is the line segment joining these 2 points. The question is, find the equation of the perpendicular bisector of this line segment. For this line, there is a perpendicular bisector. Look at this name. It's perpendicular and it's also a bisector. So this line which I have drawn is called the perpendicular bisector. Look at it. It's perpendicular, I said, which means it should make an angle of 90 degrees with AB. It's the bisector, which means it should divide AB into 2 equal parts. This part and this part should be same. Okay. So this line is perpendicular. It's also the bisector. Both are equal. Okay. So for this line, you have to find its equation. Now you'll see that this line cuts AB at the point C. Because this and this are equal, C is called the midpoint. Okay. So C is the midpoint which can be found because you know A and B, 2 extreme points. you can find the midpoint using midpoint formula. Okay. First, let's find C. So C is the midpoint of AB. So I am using this point as x1, y1 and this point as x2, y2. So this is midpoint formula. X is equal to x1 plus x2 by 2 and y is equal to y1 plus y2 by 2. So x is equal to x1 is 2 and x2 is minus 4 divided by 2. And y is equal to y1 is 7 and y2 is 1 divided by 2. So x is equal to, if you simplify this, minus 4 plus 2 is minus 2 by 2, which is minus 1. Y is equal to, this is 8 by 2, which is 4. Which means coordinates of C, the midpoint, is minus 1 and 4. So you know this coordinates of C is minus 1, 4. I'll just write it here. This is minus 1, 4. The question is, you have to find the equation of this perpendicular bisector. So on the perpendicular bisector, you know one point, that is C, whose coordinates are known. And you also know that this line and this line are perpendicular, which means their slopes must be related. So get the slope of AB, you can find the slope of this perpendicular bisector. Okay. So second thing that you have to find now is find the slope of AB. So for AB, again, AB, you know 2 points. Use these 2 points to find the slope. Slope of AB is, this is the formula. If you know 2 points, y2 minus y1 by x2 minus x1. y2 is 1 minus y1 is minus 7 divided by x2 is minus 4 and minus x1 is minus 2. This is minus 6 divided by minus 6, which will give you 1. This is the slope of AB. But what you know about this line and this line is they are perpendicular, which means the slopes are related as m1 into m2 is equal to minus 1. So m1 you know is 1. So m2 you can find. m2, if you substitute in m1 into m2 is equal to minus 1, you will get the slope of this is minus 1. Since perpendicular bisector, this one is perpendicular to AB, its slope is minus 1. If one of the slope is 1, the other one's slope will be a negative reciprocal. Okay, that's minus 1. Okay. So for this line you know slope, and for this line you know one point, that is this one. So that's what we are going to use now. So the equation of the perpendicular bisector is y minus y1 is equal to m times x minus x1. Okay. So y minus, the point that you know is 1, 4. So y minus 4 is equal to m is minus 1 times x minus 1. So minus of minus 1, that becomes plus 1. Okay. So y minus 4 is equal to, multiply this inside, minus x minus 1. Rearrange this. This comes this side, x plus y. This comes this side, minus 4 plus 1 is minus 3 equals 0. Is the equation of the perpendicular bisector. Next, question number 57. Find the equation of the diagonals of a rectangle whose sides are x is equal to minus 1, x is equal to 4, y is equal to minus 1 and y is equal to 2. These are the sides of the rectangle. First, let's draw this. This is your x-axis, this is the y-axis. Okay. I have divided the x-axis as 1, 2, 3, 4 on the positive side, negative side minus 1, minus 2. This is the meeting point of the x-axis, y-axis, this is the origin. Positive side of the y-axis, 1, 2, 3 I have divided, negative side minus 1, minus 2. Okay. Now look at these. It says these are the sides of the rectangle. First side is x is equal to minus 1. Such equations are usually, if it is x is equal to something, which means they are parallel to the y-axis. If they are y is equal to something, then they are parallel to the x-axis and passing through whatever value is mentioned. So x is equal to minus 1 means it should pass through x value minus 1 and it should be parallel to the y-axis. It should pass through x value minus 1. This is the x-axis. X value minus 1 is this. So it should pass through minus 1 and it should be parallel to the y-axis. This is the y-axis. It should be parallel to that. That's the line. This is the line x is equal to minus 1. It should be parallel to the y-axis and it should pass through x value minus 1. Okay. That's the first line I got. Next, x is equal to 4 means it should be parallel to the y-axis. It should be parallel to this and it should pass through x value 4. X value 4 is this one. And it should be parallel to the y-axis. So that's the second line. The third line is y is equal to minus 1, which means it should be parallel to the x-axis and it should pass through y value minus 1. Y value minus 1 is this and it should be parallel to the x-axis. This is the third line. And the fourth line is y is equal to 2, means it should be parallel to the x-axis. It should be parallel to the x-axis and it should pass through y value 2. Y value 2 is this. So it should be parallel to the x-axis and passing through y value 2. Now if all the four lines are drawn, okay, this is the first line, second line, third and the fourth line. Okay. When all these four lines are drawn, you will see these four lines meet at A, B, C and D. Okay. I have drawn this same figure separately. A, B, C, D, A, B, C, D. A's coordinates, x value is minus 1, y value is 2. Minus 1, 2. B's coordinates, x value is 4, y value is 2. C's coordinates are x value is 4, y value is minus 1. And D's coordinates are x value is minus 1 and y value is also minus 1. So we got all 4 points coordinates and it's a rectangle. The question said you have to find the equation of the diagonals of the rectangle. This is the rectangle. The sides of the rectangle are this, this and this. But the question is you have to find the equation of the diagonals. First diagonal is this one. AC is one diagonal, BD is the second diagonal. So first we are going to find this equation of AC. That's the first diagonal, AC. On AC, you know A, you know C. So this is x1, y1. This is x2, y2. You're going to find equation. So that's the formula for finding equation. Y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So this is x1, y1. This is x2, y2. Accordingly substitute. If you want, I'll write it above. x1, y1 and that's x2, y2. Okay. So substitute now. Y minus y1, that's minus 2, divided by y2 is minus 1 minus 2 is equal to x minus x1, that becomes plus 1, divided by x2 is 4, again plus 1. Y minus 2 by this gives you minus 3 is equal to x plus 1 divided by, that's 5. Cross multiply now. So 5 if you multiply here, 5y minus 10 is equal to multiply the minus 3 here, minus 3x minus 3. Rearrange this, x comes first, so this comes this side, 3x plus 5y, this comes this side, minus 10 plus 3 is minus 7 equals 0 is the equation of the first diagonal. Now you have to find the equation of the second diagonal. The second diagonal is this one. BD is the second diagonal for which you will find the equation. So equation of BD is, formula is the same. The same formula, y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So substitute the values. Y minus y1 is this. Y minus 2 by y2 is minus 1 minus 2 is equal to x remains the same. Minus x1 is minus 4 divided by x2 is minus 1 minus 4. And then simplify this, y minus 2 by minus 3 is equal to x minus 4 by minus 5. You can cross multiply. This will become minus 5y plus 10 is equal to minus 3x plus 12. Rearrange now, this comes this side, 3x minus 5y plus 10 minus 12 is minus 2 is equal to 0 is the equation of the second diagonal. And your homework for today is exercise 14, question numbers 38, subdivision 4, 34 and 47.